Saxon Algebra 2. Sums and products of functions. Greetings, students. This is a super practical lesson if you delve into more advanced mathematics, and this is a really good topic because it seems like it's going to be hard, but it's not. So what I want you to do right now is take a deep breath, blow it out, and tell yourself, this is going to look weird, but it's not hard. It's not hard at all, I promise you, all right? And I'm going to do my very best to explain it in a way that will make you wrap your brain right around it. Okay, functional notation is good for one thing in particular, and let me show you. Okay, this is supposed to be a, what letter is that? It's not a theta. Is it a chi? I don't know. I would Google, but my phone's busy cameraing. So this is what's cool about functional notation. Sometimes we're putting numbers through a process of different equations, a series of equations. And so it helps to give them names so that we can talk about them as individuals. You know, John does that awkward thing where he puts the A or the B. That's kind of the same idea. But here what we're doing is we're saying, let's give these different steps or processes a name. This is the H function. This is the chi function. And we have built-in names that allow us to refer to them and allow us to process the numbers in an orderly way. It's organized, you guys. That's all it is. It's like the label maker of math, okay? We can put labels on things, and that makes it easier to understand them. Now, every function also has to have a domain. That tells us these are the numbers that we're allowed to plug into those functions, right? And usually we look at the real numbers, which is broader. Real numbers includes anything that can be represented as a fraction or a decimal point or a percentage. It includes decimals as long as they repeat, right? Infinite decimals are okay if there's a pattern to them. If they're, if they're totally random, then they are irrationals. Okay, so we've got these two functions, and for whatever reason, we've decided we need to add them together. We want to add these two functions. Now, you and I don't have a reason to do that, so it seems kind of random and weird, but if we were building a rocket ship to Mars, this might make perfect sense to us. This might be a great way to solve a problem. So we just have to take it on faith that, yeah, there is a reason to do this. What we want to do is add the functions. Okay, that's what this notation means. Okay? There are two ways that we can solve this. So what we want to do is we want to find out what happens if you plug 2 into both of these functions and then add them together. There are two ways to do that. And I'll show you in just a second both of the ways. And whether you choose the first way or the second way may depend a lot upon the project that you're working on. I'll say more about that. In real life, there would be a reason to choose one over the other. For us, it feels a little random, but that's okay. That's because we're not doing this in a let's build a rocket ship to go to Mars context. The first way to do it is to literally add the functions, then solve for 2. Okay, so what we would do is we would say the h of x plus the, whatever letter that is, of x would equal x plus 3 plus x squared minus 6. Look, x plus 3 plus x squared minus 6. We literally just add them together. So then we can rewrite this as the h plus that of x equals, I'm just going to put this in order now, x squared plus x, and then that would be minus 3, right? Because it's positive 3 and negative 6. So we would combine that to that. So this is just a cleaned up version of literally taking the two things and smashing them together, right? Easy. Now we're ready to put in 2 for x. Right? And literally, we just take the value that we're interested in and we just plug it in. Everywhere where there's an x, we put in that number, and that would equal, let's see, 2 squared is 4, plus 2 minus 3. So that tells us that the value of this fancy thing we created equals 6 minus 3 is positive 3. All right? Okay, so that was the first way to do it. And this way makes sense if you want to use this combined function for multiple values, right? If we're going to be using it for more than just this one calculation of 2's, if we might be having to add a bunch of other numbers this way, then we would want to go ahead and create that function and plug in our specific value for it. But let's say that you didn't think you were going to do that. You normally would be using these separately, but just this once in our rocket ship to Mars, we're going to have to combine those two. Then you might want to do it this way. This way, we're not going to combine the functions. We're going to find the h of 2. That would be equal to 2 plus 3, right? We're just plugging it in right there. And that's 5. And then this thing of 2 would be 2 squared minus 6, which would be 4 minus 6, which would be negative 2. And then we add 5 plus negative 2, right? That's the sum function of these two. We just put those two together and we get 3, which is exactly what we got last time. So this time, we just calculated the original functions independently and then added their answers together. Again, this is good if it's more like a one and done situation, but if you think you're going to need that new function for multiple calculations, go ahead and find the formula and then calculate your specific value. Then you've got this ready if you need to do more. This is better if you just need to do it once, all right? For our purposes, I want you to be able to do it both ways. I want you to feel confident both ways. And then later on, you can start choosing the one you prefer, all right? Oh, the other thing that's important is that we recognize that this is reals, this is integers only, right? This is just the big numbers, so to speak, right? The whole numbers and the negatives. So the domain of the combined function is the smaller of the two. So it's okay, we were using 2. 2 is an integer as well as a real number, so that's perfectly fine. There might be a time though, like if the thing we were supposed to plug in was 2.5, we couldn't do it because this function is limited to integers only. So you can't plug a number in there that's not an integer. It won't work. It'll blow up the machine. There'll be sparks and smoke. Might need a fire extinguisher, which actually would be kind of fun, but that's okay. I used to be a Girl Scout leader, as you might imagine. And one time when we were talking about safety, home safety, I think, I had a relatively old fire extinguisher, so we took it out in the backyard and just practiced using it. It was really fun. I highly recommend as a form of entertainment. Okay, let's try another one. Given h of x equals x plus 3. Domain equals the reals. I'm just going to put an r. Notice how cute and simple the math is in these. The g of x equals 2x squared plus 5. And its domain equals, ready? Negative integers. I'm writing that out because it's fussy. Find the h plus g of 5. Now, this is where the alarm bells go off. We could add these together easily to create the combined h and g function, but we can't solve it for 5 because we're limited in at least one of these to negative integers, and 5 is not a negative integer. So we say null set, empty set, no solution. Okay? When you get to college and you're taking a math class, and you're missing me so much, I know. Make sure you know which of these solutions your instructor prefers. I want you to see as many as possible. A college professor would probably prefer one over another. Make sure you find out, okay? All right, so that was sums of functions. Now we're going to do the very same thing in 2 more problems, but this time we're multiplying the functions instead of adding them. It's not much harder. All right, so we're supposed to find, well, first let's look at our basic functions. We have one function called the h of x, and that allows us to add 3, and we can use that for the reals. For real, man. And then we have another function called the g of x, again. And that one is x squared minus 6. These are the first ones, aren't they? This looks very familiar to me. Oh, but this time we're multiplying. That's what it is. And this one, the domain is negative, oops, I forgot the equal sign, negative integers. All right, so we're going to be on the lookout because that's a very specific domain. We're supposed to find the h times g of negative 4. That's an h, okay? Now, the first thing we want to do, because we learned from that tricky one, didn't we? Check this against our domains before we even begin. Because if it's not going to work, why even bother, right? But this one's going to work. It fits, right? This is negative integers. And negative 4 is indeed a negative integer, so we're good. So now we have 2 approaches. The first one is to combine the functions first. And so we would take the h of x and multiply it by the g of x. And what that would look like is we'd take x plus 3 and multiply it by x squared minus 6. Now, that's a little more annoying, isn't it? Because we have to do this multiplication. But we can do it. X plus 3, x squared minus 6. We have to multiply the binomials. So this is going to be x cubed plus 3x squared minus 6x minus 18. I did the dance there, right? I multiplied up and over, and then up and over. Ay, ay, ay. That's kind of an ugly function, right? But that's okay. 3x squared minus 6x minus 18. That is the hg of x. That's our new combined function that we got from multiplying those 2 together. Now we want to solve it for minus 4. Oh wait, I did something wrong here. No, I didn't. I'm just double checking to make sure this, oh, I just copied it wrong. I copied it, oh, I see what I did. I left off the first term. It's x cubed plus 3x squared minus 6x minus 18. I just forgot the first term, didn't I? I forgot the x cubed. And I just copied that part. Okay, I'm back on track, right? Now we need to plug in, I'll go down here. We want to find the hg of minus 4, so that means we plug minus 4 in everywhere there was an x. So it'll be minus 4 to the third plus 3 times minus 4 squared. I'll let you copy that. I just wrote minus 4 in a bucket everywhere there was an x. This part is easy, you guys. Everybody gets freaked out by this front part. I understand. But what we're doing is super easy. It's just that evaluate thing that we've done a long time. Okay, now we just need to simplify all of this. 4 cubed is 64. And there's a minus sign that went along for the ride, so that means there would be 3 of them, and that means I'd end up with a minus 64. This is going to be positive 16, right? And then we multiply it by 3, that's going to be 48, and it's plus 48. This is going to be plus 24, and then minus 18. Oh, that's crazy. Let's put the minuses together, and then let's put the pluses together. I want to do the pluses first. 72 minus 82? Yes. So our final answer is that the hg of minus 4 equals negative 10. All right? Awesome. This is the way we would want to approach our problem if we knew we were going to have to be calculating a number of values for this product function, right? Let's go ahead and create it. And then we could plug in multiple values for x. Just as a reality check, at this point in the world, all of this would be done on computers. We would just be writing program to do this. And that's what would be cool, is if we created a program that could do this, then we could kick values in there all day long and it wouldn't hurt a thing. Okay, but we're not. We're scratching it out on pencil and paper, old school here. Now we're gonna do it the other way, where instead of combining the functions and then plugging it in, we're gonna plug it in and then multiply. And I'm getting a backup piece of paper because I don't want to have to copy all of this to the other page. Oh, here's where my problem starts. All right, so what we're going to do, we're going to find the h of minus 4, and then we're going to find the g of minus 4, and then we will multiply those two answers together. So there's the h. That means it's going to be minus 4 plus 3. I'm just plugging in, right? The x goes where the x is. And so that equals negative 1. And the g of 4 is x squared, so that'll be minus 4 squared minus 6. This is positive 16, so this is going to be equal to 10. And then to get the product, I just multiply my two answers together. So it'll be minus 1 times 10, and that equals minus 10. And that, my friends, is the same answer, right? Here, I'll push up a little bit so you can see. Two different approaches. Again, this second approach, which I didn't write this down. Solve the functions one at a time, right? That's what we did here. And then multiply the answers. That's what we did there. This works best in a real life situation. This works best when you're in one and done mode. And you're not going to need to use this product function in the future. That works great. In homework, this one's honestly faster, but I want you to feel comfortable doing it the other way too. And then our last problem, I guess I'll switch back to this. Is one of those trick scenarios where I'm not even going to write it down. I'll just show you the book. It says, find the f times g of -4, where f equals blah, 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 domain equals the reals. Okay, that's fine. And g equals blah, 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 domain equals positive integers. But we've been asked to plug in -4, and we're not allowed to do that with the g function. You can't plug a negative integer into g. It's positives only. So the problem blows up and comes to a standstill, and we do null set, empty set, or no solution also is a way to write the answer. All right? So check the domains against the number you've been told to input. And if they don't line up, that's your answer. Satisfying, right? Yay! That is lesson 102. I hope you enjoyed it as much as I did. Please don't be afraid of functional notation. It's not hard, it's just different, as life often is. Okay, I'm done. Goodbye.